In this video, we're going to differentiate a power series. So let's say you've got a function defined by this power series. Well, this power series will generate all these terms because when n equals 0, you would put 0 into this n, and then you would put 0 into this n here. So here you've got something to the power of 0, something to the power of 0. Well, this thing here will be 1. Anything to the power of 0 is 1. So you've got a0 for your first term. So for your first term, it would be a0. And then your next term will be n equals 1. So you put 1 into here, that will then give you this, and then put 1 into here. So that will be this whole thing to the power of 1, which is this whole thing here. And when n equals 2, it will then give you this term. When n equals 3, it will then give you this term. So this power series will generate all these terms all the way to infinity. Or you can actually differentiate. You can actually differentiate each individual term. So when you differentiate this, it will be 0. And then when you differentiate this, it will be well, you should already know how to do this. If you differentiate this, if you differentiate this, it's like me giving you, let's say a is 3, and then x minus, let's say 2, and then imagine this to be the 1, because this now is very similar to this. So if I were to give you this, if you were to differentiate this, it would be 3, 3, and then the bubble stays intact. The bubble stays intact. X minus 2, and then the power gets minus. This power gets minus by 1. So that will then give you 0. Well, this thing here is 1. Anything to the power of 0 is 1. So you're left with this constant here. So when you differentiate this, you're just left with a constant a1. And then when you differentiate this, bear with me. When you differentiate this, you would imagine this in your mind. So let's just say this is 3, and then you've got your bracket x minus, let's say 2 to the power of 2. So if you were to differentiate this, you would imagine this as being a bubble here. So this would come down here. So that will give you that will then give you 6. That will then give you 2 times 3, and then the bubble stays intact. X minus 2, and then this power gets minus by 1. So when you differentiate this, notice that this bubble here stays intact. So this bubble here stays intact, and then well, remember the 2 will come down here, so that will then give you 2a2, and then the power gets minus by 1, so it would be 1. So now when you differentiate this, the 3 will come down here, so that will be 3a3. The bubble stays intact, x minus c, and then the power gets minus by 1. So that will then give you this, and then so on. So when you differentiate this whole thing here, it will then give you this. So now you can now convert this back into a summation form. So if you look at it, you can now convert it back into a summation form. So if you look at this, your first term is when n equals 1. So this is your first term here. Notice that each time the bubble here stays intact. Each time the bubble stays intact, but then it gets incremented by 1 each time. So here the bubble stays intact is 1. The bubble stays intact 2. The next one would be the bubble stays intact 3, and so on. So this is your bubble staying intact each time, and then it gets incremented. But notice that this thing here, 1. Notice that this thing here is always 1 more than this. So notice that this n here is always 1 more than this. Well, think about it. You can rewrite this and then convert it into a summation form. But just remember that your first term here disappears. So when you differentiate this, it disappears. That's why you start at 1 as opposed to 0 up here. Well, think about it. You can convert this thing into this thing here. So when given this, you can actually differentiate it like this. So it becomes n a n, and then the bubble stays intact. The bubble stays intact, and then the power gets minus by 1. The power gets minus by 1. It's kind of strange, but you can actually differentiate a summation, and it gives you this. But just remember, it starts at 1. Okay, and then once you get to this stage here, you can differentiate each individual term. Well, the same is true. You can actually integrate each individual term as well, which we will tackle in the next video.